Well, I was going to do a rock star entrance after Dave's introduction, but for 7 people, I decided that that'd be a little bit much even for me. This is info. I am working for Bluehost. One of the first hacking jobs I ever did was on who knows what this game was or is? Anyone remember it? Ultima 1. The very beginning, the first real computer game I ever played, but I did play it on the Apple IIe, so let me fix that for us. There we go. Oh, see, this is what happens when you edit your talk while you're on Ambien. So I think that's just a little bit too much. But as I said, I work for Bluehost. We're always looking for people. So basically, if you're not on Bluehost, you probably will be. In fact, oh wow, awesome. That's Bluehost absorbing everybody. Did anyone remember this movie? Sorry, is that too obscure?
What is that?
That's The Blob with Steve McQueen. No one remembers that. Man, I didn't think that. I'm used to being obscure, but all right. Anyways, oh my gosh! Thank goodness for the transitions. Okay, so a little bit more about me. My brushes with greatness. Back when I was starting, I worked on the worst movie ever made. And if you doubt that, it's the movie responsible for this. Sorry, there was supposed to be a little interim before that one popped up, but I actually did 3D head scanning for them. So we scanned their heads. We digitized their heads for some of the first work. And then when I was younger on the Spanish Steps, I was talking with a friend. I'll let you decide which one I am. Okay, this was working pretty well when I was just over there. So I guess, when someone came walking down the stairs. And we looked at their feet. Maybe I'm not networked up. And they had really pointy shoes. So, of course, my friend at the time all right, let's oh, no wonder.
Why was you're on a map? I haven't seen these ones. Let's see, listed there any of the ones we're supposed to use. Are you tethering?
Yeah, must have turned off after I didn't connect. There we go. Should I start over with really speedy stuff now? Well, that's not going to be good.
start from there.
Okay, I guess it was just waiting. So she said, "Those sure are pointy shoes." Then later we found out that was Simon Le Bon. So we mocked Simon Le Bon's pointy shoes right in front of him. So I've got that going for me. All right, so a couple years ago, I was working on a project, the Connects Rules engine, and we had a problem we were trying to solve. And as of everything, all great things are born out of need, and this one was also born out of need. So our Connects Rule engine, see, I'm a little bit nervous because the architect is sitting in front of me, but what we did with it is we were providing enduring, consistent persistence across browsers, platforms, and devices. So it was an application engine that at the time we were using for web mashups, providing a very strong identity layer. But what we were trying to do is to insulate the user's identity from the developer. So we were providing kind of the identity layer that the developer could piggyback on without giving all of the user information to every developer. So it was our cloud application engine. Kind of an interesting thing about it is we had a dual execution environment. Our servers were Apache running mod Perl, and then on the browsers we had a JavaScript runtime. So that's one of the ways, by processing a lot of this stuff on the server, we were able to hide a lot of the information that otherwise JavaScript would expose. Now this was a domain-specific language, rules-based, so we had a special parser for it, which would generate an abstract syntax tree that then we would follow to execute whatever program the developer wrote. And at the time, we were just using memcache as our persistence layer. So one of the problems with memcache is it's a cache. So if something happens, if something happened to the servers, everything would go away. And it was working okay, but our developers wanted something a little bit more. Well, they wanted a lot more, but so what we're trying to do is we're trying to strengthen. Hello, Davey. How are you today? Okay, but our clues on this, or my marching orders, were to minimize disruption because we had a huge installed base. Well, I don't know about huge. We had a significant installed base of developers and rules already that we didn't want to break. I needed to add functionality, not change it. Once again, keep the developers happy. And personally, I wanted to avoid changing the parser because we'll leave it at that. Anyways, the parser was, at the time we were using JSON parser, a Perl parser, left recursive. And is anyone familiar with JSON parser? He is. Anyways, it's a little bit scary sometimes. So we were looking for a new persistence layer. And two of the elements that we were looking at were MongoDB and Cassandra. Now, just these are NoSQL databases. So is everyone familiar with the NoSQL paradigm? Anyways, I also like this. Because you're always in a balancing act between consistency, availability, and partition tolerance. Okay, and I like the diagram because it shows where the different NoSQL options kind of fall in that area. So Cassandra was very much highly available. Mongo had a lot more understanding of geolocation and stuff like that. Come on in. I know, one demerit. Okay, so when we were looking at the positive elements of MongoDB was blazing fast. Of course, nothing was going to be as fast as Memcache. Okay, because it's cached, thank you. But a really exciting thing for us is that all of the data is stored in binary JSON. And we had adopted JSON as our underlying data format of choice, partly because we're using JavaScript in the runtime, but also partly because XML blows. So, and also the engine has a JavaScript interpreter in it, so you could, if you wanted to, write custom queries in JavaScript. And the nice thing about it is, since it's running binary JSON, it was document oriented. So you didn't have to configure rows and values of tables. You could just shove whatever you wanted into each entry. Okay, the negative elements is, at the time, your document could only be about 2 meg. Of course, as they pointed out, Moby Dick is only about 200K long. So for most purposes, at least for what we were doing, we were pretty okay with that. It had a new query syntax. It was JSON-ish. Actually, it was JSON-like. But it's not really something that I wanted to expose to our developers. For one, because we're trying to insulate the customer from the developer, and I didn't want them to be able, I wanted them to have to go through my filter as the application engine in order to get any data, so I could make sure that they weren't grabbing something they didn't have to. Data center awareness, I think they're doing a little bit better about that now, but it didn't have good data center awareness. Of course, at the time, we only had one data center, so that's not a big problem. And supposedly they've gotten better at, though Cassandra still says that they don't have a long history of data center awareness.
If I can interject, it turned out for our application it didn't matter because it would be easy for us to shard per data center.
Right.
So it wasn't a big deal.
Yeah, that's another thing that I wasn't going to get into, but sharding allows you to put data in different locations based on some of your indexes and your keys. So it actually allows you, and since I didn't really say this, Mongo has excellent geospatial awareness. I think this comes up later. So you can put the data closest to the customer if you have the right index. And then there's also this issue of global lock. They've been doing stuff more with it. A lot of people had mentioned that. We never really saw that coming into play. So either we didn't have the data contention that other people were doing, or we didn't see that as an issue.
That's a per document thing, isn't it?
No, that's a global database-wide lock. So it's kind of makes people scared, but the way they do it, it doesn't come into play very much as far as I can tell. But I think they've changed that. All right, so the limitations of MongoDB were that it's very memory hungry. Okay, all of the indexes are placed into RAM. Do they still call it RAM? Okay, so that your lookups and your index lookups are blazing fast, And they try and keep as much of the data in RAM as well. So you need a machine with lots of RAM in order to make it work well. But RAM's pretty cheap and it's easy to scale your RAM up. So it's a limitation, but it's not a killer. Disk performance, we found out, is very vital. Since it's all disk-based, Mongo pretty much formats, knows where it's going to place everything before it places it. Does that make sense? So it builds this map and it already knows where things are. The next thing that goes, it knows where it's going to be, so it doesn't have to rebuild anything. But because of that, if your disk is not fast, you'll run into some really bad latency problems. And journaling, the way that it distributes to its secondary servers. That's not the right word. Who knows the right word? The primary. You can have it in a master slave, but they're replica sets. The way it distributes to the replica sets is through a journal from the master. Okay, and if you happen to have that journal on a slow disk, you're going to run into a lot of problems and you're not going to really know why. But we actually came up at a point when we were doing this wrong where our journal, when we took a server down, a MongoDB replica set down, and we turned it back on, what happens is the replica set just grabs that journal and does a replay of it. But because of this slow disk that we had, the journal could never catch up to the master disk. So that was, that was something that, as soon as we knew what it was something that we could fix. But it is something that, if you're going to host this on a virtual server like Bluehost, or on Apache, you need to choose the high performance disk, because the just the normal disk that they have turns out to not be quite fast enough for the purposes. Okay, so the features of MongoDB that are really cool are something called capped collections. Okay, capped collection is a stack that you can just push your data in and everything on the other end will fall out. Okay, so you can say, I want 100,000 records, and you can push your log on that, and you'll never have to worry about your logs overcoming your storage, because once they get expired out, they're gone. And you can use that for a number of convenient things. The other thing that is really great, did I mention that indexes were cool? Is they have time to live indexes. And time to live indexes are, if you set a date field on your document, and remember your document can be anything. You can, if you put a date field and you index it in there, you can say if that date field is 5 minutes expired, it'll just garbage collect that for you. Does that every minute, so it's not a very thing that you want to count on for preciseness. But if you want to just make sure that you've got records that you want to keep around for a while just to make sure, another case would be logs that you don't need to keep but would be helpful to have for a couple weeks until it doesn't matter anymore. And then I did mention the geospatial indexes, where you can put data on the server that's closest. And also you can do queries based on location, where you can say, give me anything within a 5-mile radius of this value in the database. So that is one of the reasons I imagine that's one of the reasons why Foursquare uses it, is because it makes that very, very easy. Oh, sorry, did I skip over Cassandra? Yeah, I did. That's because Cassandra was a pain in the butt to configure. And one day, one of our engineers said, oh, by the way, I got a Mongo server up this morning. And I started using it, and, well, I didn't turn back. So Cassandra could be nice and lovely, but at the time it was not fun to set up, and it didn't quite meet our needs. Now, as I was doing my research, I noticed that Mongo had this ancestor pattern in it. And through this ancestor pattern, you could represent complex data. Now, what kind of data store is Memcache? Key value. Okay, so if you want to store something in Memcache, you have key and a value, and that's about it. But with this, I realized, and that was kind of the limitation of what we were doing, is our database was pretty flat because we didn't have the ability to go in and index on anything down below. But now with Mongo, we did on the data. And so basically by giving what I call a hash path or a hash map, you could define the location of every element in your tree just by a simple array of the keys. So with that, I realized we can support more than just key value. We can start storing hash maps like this, complex data structures, and then provide access, random, do we call it random access? I mean, that's what you do in disk, but on-demand access deep into the bowels of the hash without having to parse it through, which when you're on the web and you're trying to do things is a pretty nice benefit when you haven't had that before. And then I can store stuff based on this hash map. I can put the value of B in there, and then I can go in and I can prune stuff. And so basically from there, I needed to come up with a good way of serializing the data. Now, I had already experimented with decomposing hashes because of some of the work I was doing with Facebook and Amazon, is I would take the hash apart so that I could search it a little bit easier.
Mark?
Yeah.
Mongo stores JSON natively. Why did you serialize the data?
It's a good question. So one of the things that I was concerned about at that time was the 2 meg document size. And I also wanted lookups to be as fast as they possibly could when I could do it. So if I stored everything, if I flattened things out like this, basically on that hash map, I could pull individual elements of the hash straight from the Mongo database without having to do a more complex search index on it, and without having to transfer the entire element. So if I had a huge tree, and we actually ran into this, if I have a huge tree and I only need a portion of it, with this, by giving just the hash map that we need, I can only return the stuff that I want. So that's the reason why I flattened it out. And with all things, there comes a little sunshine. I think we found out with about 60,000 elements of a hash starts to bog down. Well, that's 60,000. At the time, I don't think we ever thought we'd have any. I mean, we were going key value store at the time. So I was okay with the trade-off. If you can think of a better way, this is an open source project, so we'd be more than happy to. So we're talking about the serialization. And as I said, I had figured out, I had done some work in decomposing the hash into an array of data with that hash map as a key and then the value. But putting it back together again, it was getting a little bit messy. I didn't want to have to do all the parsing. So I actually found this module called DataDiver. Okay, and DataDiver actually gives you a way to do exactly that. You can use that hash map and go down into and get values out of your hash map. One of the things I forgot to put it in this is before the way we were using to get stuff in your hash was via JSON path. Has anyone ever used JSON path? Has anyone used XPath? Because it's a lot like that. That turns out to be not a very easily learned concept for developers. So having them use JSON path, it's wildly flexible, and you can do a lot of globbing on it, so you can use expressions to get down and stuff. But our developers, almost to a T, always had problems with getting the right data out of it. So by doing this, I was able to give them a lot easier way to peer into their hash. Okay, and this did the hard work for me. Okay, so this is the Decomposed utility that I kind of already had in my work, where I just went through, parsed the keys, and pushed them all into an element. Nothing very exciting about that. But then, taking that array and pulling it back out and deciding whether or not to vivify branches, that you may get it out of order. So you have the branch, but then how do you if you create a branch but then you have another element later on that you need to add into it, you get into some memory issues where you're going to be overwriting stuff that you thought. But DataDiver gave me a way to assemble it very easily. So I just parsed over all of the elements and used dive_val with, this is my object, the path, and I just set the value in there. So I didn't have to worry about vivifying. It would auto-vivify as it felt it was needed. Took care of all of that, and the code is actually pretty simple. It's a C in Perl, so I wouldn't want to try and debug it. But kudos to the guy who wrote it.
That was tight.
Yeah. Do you know him?
I know. Yeah.
Of him? Okay, so now I had my Mongo database. There's a Perl driver for Mongo. Pretty dead simple to use it. You just define your connection and you make your connection. Then you establish which database that you're going to connect to, because Mongo can support many databases. I'm not sure if there's a limitation, I realize. But Mongo's pretty good about auto-creating anything. So I know for collections, if you try and store something in a collection that it hasn't known about, it'll auto-create that collection for you. And creating a new database is as easy as saying, here, I've got this name, make a database out of it. So you can have many databases in it. We only had the one database, so we didn't really have to worry about it. And then everything is stored in a collection. And your collection is just a group of those JSON documents. So you have to, you name your collection and you apply indexes onto a collection. Now this should be pretty familiar to anyone who's done any Perl DBD stuff, right? They did a good job of making it very similar. Okay, so in actually implementing it, so this is just a simple getter. It became, now there was a lot more wrapped up with this because we had identity elements and rule set elements. I just totally waved over for you guys. But your find statement is as simple as just pretty much providing that hash key. You can give it a name. Well, the way I set it up with as a document that they all had a key field and then a value field. And then they had that ancestor field. So based on that, if I wanted the whole thing, all I had to do was say the key is the key field. If I just wanted a little bit of part of the element, I could say, well, give me the key and then everything that matches the array of these keys. So became find, it gave you a cursor, and then with that cursor, okay. So, and this is what a key looks like. And so the key would be I greater than 42. So mine were a lot more complex than that because of what we were doing, but they don't have to be. And there's a lot of ways that you can go in and query on it. And then because I got all of the elements I wanted, I could just come back like you saw before and put this into the hash and then return the hash. And so.
By the way, this is a really cool construct right there because it shows Perl having function on the left-hand side of the question.
Yeah.
A pretty interesting linguistic construct, aside from everything else you're talking about.
Right.
Yeah.
Yeah, that is true. It did take me a while to kind of grok the way that was happening, but
Essentially calculate the left-hand side of it.
right, and then put it in there.
Yeah.
So it's
Just from a pure Perl standpoint, it's pretty cool.
yeah.
It's harder to write the sub. The actual drive value sub is pretty hard to write.
Yeah.
Sub.
And this is, I mean, the way it happens is that makes it a lot quicker too. The way to do it, you don't have to build it, find it, vivify it, and then shove it in. It's kind of okay. And so because these are all, when we break it apart, I don't want to do an insert for each one because that's dumb. But Mongo has a batch insert. So I can just give it this array of elements that have changed. Give it to that, and then Mongo will take it and insert it. So that took care of one of the worries that I had that, a single insert every time was going to be untenable. And then this is just this is what we were inserting. I mean, if we didn't have the bulk insert, I would have had to do one of these for every element. Okay, but with the bulk insert, I would just give them, this array, and it would just parse that all on Mongo where we've got the resources available. So, in conclusion, there's a lot of Mongo haters out there. Probably because it became the flavor of the day and everyone was like Mongo this and Mongo that. But when I went through and read the blogs, I always found that they really were trying to do something with Mongo that you shouldn't do. I mean, Mongo and NoSQL, if you're trying to use Mongo, Mongo does have references, so you can do references to other collections and other entities. But that's not really its strong point. So if you're trying to use Mongo like a relational database, use a relational database. Okay? Play to Mongo's strengths. So if Mongo is our round peg, and we've got our square hole, you probably could fit that in if you really squoze it, but don't do it. All right, that's all I've got. Any questions about implementing Mongo? You know what? The Mongo guy just asked me that. And I would like to see how Mongo performs on our new VPS host, on our virtualized host. So I'm going to try and play with that. I don't know if they're ever going to productize it. But with something like Docker, with one of our VPS hosts, you could easily install it. I mean, I don't think Mongo will ever make it to our shared hosts just because there's really not enough power on that virtual host to run Mongo properly. I mean, I guess if all you were doing was key value, it'd probably work, but this is kind of a, oh, thank you, Firefox, one of the million times. We had an argument over chat the other day about Firefox versus Chrome.
Oh, yeah. So can I take a minute just to do a small advertisement for the Kinetic version?
Oh, yeah, sorry. This is the GitHub. Go ahead, I'll let you do it.
It's an open source project. It is a rules engine that runs a language called Perl. The whole thing is written as an Apache Perl, mod Perl module. So we use Apache as the application server, so to speak. As an example, if you send in an asynchronous event, that's all Apache doing that. The rules engine has made it to the point where it's very usable for Internet of Things kind of things. I built a connected car platform called Fuse on top of it, which is Mark was talking about where we ran into the 60,000 item getting slow thing.
Turns out there's a lot of data elements in a car trip.
Yeah, you store every trip, and every trip has a bunch of elements, and you start running into this. So we're trying to resolve that, but there's a lot of cool Perl stuff in there. And,
yeah, anyone can go in and dive in.
Have help with some of the stuff. If you're interested in Internet of Things, if you're interested in rules languages, if you're interested in Perl or Mongo, this would be a good project to spend some time having fun.
We really should have had you at some of the hardware sessions yesterday. Anyone else? All right, thank you very much. You've been very kind. Are there any students? I don't think there are any students here. Oh yeah, you're UVU?
Yes.
Sorry?
UVU.
No, I heard. I just said sorry. I'm sorry. I've been waiting. I was hoping there'd be more people so I could do that on BYU, but when we... Oh, are you? Are you doing the advanced? Cool. That's a great thing. If you guys have kids, Utah has concurrent enrollment, where the kids can graduate with their associate degree actually before they get their high school degree. And if you do that, you can qualify for the Century Scholarship, which gives you...
$1,250.
Okay, say that again.
$1,250 a semester currently for 2 years.
So that is a great deal if you're trying to get your kids through. Of course, you have to go to a Utah State-sponsored school. Okay. But I put $1 through it, and she's a freshman, but she's already going to apply for her nursing program this year. So,
What school?
Utah University.
University of Utah.
Yeah.
Okay, that's fine.
Sorry, I was thinking left recursion there, so I was putting the one before the other.
You just say you.
You.
That's right. So you.
Okay. Thank you.
Thanks, Mark.
Thanks, Mark.